Hi, Math 1052 students. I'm going to do the unit review in this video today for question number 12 to help you prepare for the Unit 3 exam. Okay, so question number 12 reads, a nursery sells a bouquet of roses for $14 each. The variable costs are $8.50 per bouquet, $8.50 per bouquet, and the fixed costs per week are $2,700. So question A of number 12 is to calculate the break-even number of bouquets to be sold per week. All right, and here's how you do this. So the first of all, you have to let X equals the break-even number. Right, so the equation would be total revenue equals total cost, right? And the specifics of this equation are as follows. Selling price multiplied by X, which is the break-even number, equals fixed costs plus variable costs multiplied by the break-even number. So this is the formula you have to keep in mind. So total cost equals this part of the equation. This is total revenue. Total revenue rather. Total cost is the other side of the equation, right here. This is total costs. Total cost. Okay, so the trick with this sort of problem is simply to plug in the values of what you're given and then solve the algebraic expression accordingly. So we got to go back to the word problem. So a nursery sells the bouquet of roses for $14 each. The first sentence, we have the first given, which is $14, and that's the selling price. So we plug in $14 here, bring down X, which is the break-even number, equals, and we go on. Go back to the word problem. The next sentence, the variable costs are $8.50 per bouquet. So $8.50, that's the variable cost, goes down here. $8.50. X goes down as well. So $8.50 multiplied by the break-even number. Go back to the word problem. We find out that the fixed costs per week are $2,700. So we plug in there. Fixed costs over here, $2,700. Coming down, $2,700 here. Bring the plus down, and you have the algebraic expression that you have to solve. Now the next step is to isolate X to one side of the equation and the constants or the other numbers to the other side. Okay, so to do this, first we need to bring the 850X to the other side of the equation. To do that, we subtract both sides by 850X, right? Again, from algebra, we know that if we do the same thing on both sides of the equation remains equal. That's why we can do this, right? So if we subtract 850 from both sides of the equation, this disappears or cancels out. This one goes down, so it'll be 2,700 equals goes down here, right? And 14x minus 850x would equal 5.5x. Now we want x to be isolated without the 5.5 coefficient. Divide both sides by 5.5. Right? Again, if we divide or multiply or add or subtract the same thing from both sides of the equation remains equal in algebra. This will cancel out to leave the x isolated without a coefficient. And we simply solve 2,700 divided by 5.5. You use your calculators and you'll get 490.9090, so on and so on. You also know that the rule in rounding the break-even number is to round up, not to round down. It's got to be rounding up, so that will be 491 bouquets. Important to also give what the units are. So this is the complete answer. The break-even x, or the break-even number, is therefore 491 bouquets. All right, proceeding to part B of the problem. Part B is, what is the net income in which 900 bouquets are sold? Okay, so in this case, we're looking for net income, and we're given the number of bouquets. So this is similar to a break-even problem, but not quite. Okay, so the equation to remember is the net income equation, which is net income equals total revenue minus total costs. Okay, that's the general formula. The specific formula is as follows. So net income equals selling price multiplied by X, which is not the break-even volume this time, but the volume that's given, which is 900, minus total cost. Total cost is equal to the following. Fixed costs plus variable costs multiplied by the production volume. Again, in this case, it's 900. This is not the break-even volume at this point. Okay, so that is the formula we have in mind. Now we simply plug in and go back to the main word problem. All right, so the main word problem, we know that the price of the roses is $14. So we simply plug in. So $14 goes down here. $14 multiplied by X, which is given in part B of the problem. All right, so X would be 900. So you multiply 14 by 900. And you subtract the total cost, which is, again, this is the total cost. Total cost. This is the total revenue, right? So it's similar to the break-even, but not quite. Okay, let me continue plugging in. So fixed cost, we go back to the main word problem. We know that's 2,700. Put the brackets there. 2,700 plus goes down. Variable cost, we know that from the main part of the word problem. That's 850, right? So 850 goes down here. Multiplied by X, that's 900 from part B of the problem. Multiplied by 900. Okay, so now there are no more variables in the equation, so we apply bed mass, which is the order of operations, brackets, exponents, division, multiplication, addition, and subtraction. Okay, now to continue, so we do the multiplications first. So 8.5 multiplied by 900. Let's go to the calculator here. That's 900 multiplied by 8.5. That would be 7,650. Do the same thing over here. This multiplication first. Clear that up. 14 times 900 equals 12,600. Okay, so then minus 2,700 plus 7,650. Add this together here. All right, that will be 2,700 plus 7,650 will be 10,350. That'll be negative. Bring down 12,600. Okay. This becomes 12,600 minus 10,350. That'll be 2,250. So that's your net income. All right, now part C of the problem is as follows. Calculate the number of bouquets to be sold to earn a profit of $1,000 per week. Now this problem is, again, it's not break even, but this is a net income problem. Right, so we get the net income formula. And net income equals total revenue minus total costs. Okay, now we know from part C of the problem that we need to know the number of bouquets to be sold when earning a profit of $1,000 per week. So $1,000, that's actually the net income. So that plugs in here. So it'll be $1,000 equals total revenue minus total cost. Okay. Now, again, we get back to the specifics. If you remember from part B of the problem, what total cost and total minus total from what total revenue minus total cost is. So we go selling price multiplied by the by X, which is now the unknown. Actually, that's the number of bouquets that we need to figure out. So this is an unknown in this particular part of the problem. Minus fixed costs plus variable costs multiplied by X, which is the unknown quantity we need to find out in order to get this particular net income here. Okay, so we proceed, 1,000 goes down. Now we can actually still continue to plug in as we did in the previous parts of the question. So S, we know S is 14 from the main word problem. 14 goes down. X goes down as well. 2,700, that's the fixed cost. We know this from the word problem. So that's 2,700 plus these variable cost multiplied by X. 8.5 goes down here because we know that's the variable cost. It remains the same. 8.5X there. Okay, so now we get rid of the brackets. So that's 1,000 equals 14X minus 2,700 minus 8.5x, because 8.5 goes into both terms within the brackets. Okay, now continue to simplify. We need to put all the x's to one side and all the constants or numbers to the other side, right? So we get 14x to bring it to the other side here. So if it goes to the other side of the equation, that means we subtract 14x from both sides, right? This cancels out. This goes down, negative 14x. Okay, so then this one, we add 8.5x to both sides of the equation, plus 8.5x, right? This cancels out. This goes down here, 8.5x. The 1,000, we need to bring it to the other part of the equation. So we add, we subtract $1,000 from both sides of the equation here. So that becomes negative 1,000 minus 2,700. Okay. So then we continue to simplify this part of the equation. Negative 14x plus 8.5, this becomes 5 negative 5.5x equals negative, we add this together, that'll be 3,700. Now we want to isolate x here, so we need to divide both sides of the equation by negative 5.5, negative 5.5, right? This cancels out, isolating x here. So the negatives cancel out as well. So it'll be 3,700 divided by 5.5 to equal 672.7272 as the quantity. And as the same with the break-even quantity, we always round up, so that will be 673 bouquets. That's your answer for part C. Thank you.